Here I'm going to show you how to calibrate your data using the ExpertEyes software. Once you have done running the eye model fit, you just need to load the information here, clicking the reload information button for the eye and for the scene. Here we have only 3,000 frames because it's just a calibration, an example that you also can download from our website, so you can play around with it. And you can, now that it's finished, you can just go ahead and click the button here, Calibrate. Here the software will go into the calibration screen, and as you can see your eye data and your scene data displayed here. On top of the eye is the model of the pupil and the corneal reflection. Here we have one slider that will allow you to just jump into any moment of the recording. And this other slider is going to allow you to actually play a number of frames. You skip it. As you can see, now we're playing 20 frames, 30, and so on. Here we have just coordinates. These coordinates for calibration they have nothing to do with the actual calibration. What we use them for is as a reference of where we're actually putting the calibration points. You will see that will make sense whenever I start doing it. So if we just go ahead and try to find our calibration dots, which are right here, we're going to select the primary calibration, and I'm going to say, okay, that dot is right here in the top left corner, so I'm going to be using the top left corner here as well. I'm going to click that M that stands for mark, and I'm going to be marking frames that belong from this position of the eye to this position in the screen. So once I'm done and I have marked all these frames that I'm going to be using for the calibration, I unclick the M, the marking tool, and the screen will change and it will go into the full scene image, where I can select where the calibration point is located. Once I do that, you can see that green cross is going to appear on the screen. You can change it as much as you want. Try to be as accurate as possible, although the algorithm does a pretty good job. Once you're done, click done, and now all those points, those 20 frames, are assigned into that position, and you just need to move forward. So let's do the next one, which is top right corner. So I'm going to click here, the top right corner, and I'm going to click mark, and I'm going to add some of these frames. Once I'm done, I unclick, I'll go back into the full scene image, but this time the calibration point is on the other side, so I just scroll back there and select the center of it. That green cross appears again, and I click done. Now these eye positions are associated with this scene position as well. And now you just have to repeat this process over and over for all your calibration points. I'm going to do a third one, which is here in the right, but in the middle of the screen. So I'm going to just go and click here, click mark, add some frames. Now unclick mark, scroll down here, select the center of it, and click done. Now you just have to go ahead and keep doing this for all your calibration points. Here in this example, I'm just showing you a primary calibration, but you most probably will need to do a secondary calibration at the end of your experiment, and drift correction points maybe after a certain amount of trials or after each trial, depending on how much accuracy you need and how much movement do you have in your task. Once you're done doing all the calibration points, as you can see here, you just can start processing them. You will see that a new window will appear and it will show you the results in real time on how is it doing. It will take a couple of minutes. This process is not reading, as you can see there, is finding the points. I was saying that this process doesn't take very long. It depends on how many frames you actually selected. But as you can see, it's doing a pretty good job. Once the software is done processing the calibration points, you can select the fitting equation, second degree or third degree. You can select if you want to use the corner reflection in your calculation, and you can see how the calibration is actually doing. Here you can see the calibration, where these green dots are the ground truths, or the calibration points that you actually select in the previous step, and all these red dots is the actual fixation points. So you can see we have a fairly good accuracy in the center, and we kind of lose accuracy in the corners, but it's fine since this data set is just a dummy data set. So let's see how we do with the third degree polynomial, and we'll have to redo it. Now this time actually we are doing a little bit better. We're doing a lot better actually. And here it might be also because of the corner reflection. So if you decide not to use the corner reflection in your calculations, you might actually improve even more. So right now, without using the corner reflection, you can see how our accuracy gets a lot better. So third degree polynomial and with no corner reflection, I think is the parameters for this data set at least. If we were to have secondary calibration at the end of our experiment, and as I was telling you, this data set is just a dummy data set, someone just staring at these calibration points, and that's it. If it was a real experiment, you will be using secondary calibration at the end, and most probably drift correction points at certain points after every certain amount of trials. If you would have that here in view, you could select which one of the calibrations you want to use. So for example, if your primary calibration is better, and then you have almost no drift of the equipment or no movement at all, you might actually want to stick with primary calibration. If you, on the other hand, if you want to use the secondary calibration, you can select it. Although the one that we use the most is the linear interpolation, which uses a combination of the primary, the secondary, and of course the drift correction points when available. So let's say linear interpolation, although here we don't have secondary nor drift correction, so it's going to be using the primary anyway. Once you have selected the fitting equation, and if you're going to be using the corner reflection or not, and once you click Calibrate, you're going to see these crosshairs, which tells you where the eye is actually looking at. So at these points, you can see how the eye is actually looking at those calibration points. So remember to actually always do secondary calibration points whenever you have them available, and also do drift correction points whenever you have them available as well.